Alright, second car on the Kentucky road trip. We got a 2008 Chevy HHR with the turbo. This is the SS fast car model. And what's the customer complaint? Well, it starts up, it runs kind of rough, and then it says the engine power reduced. Let's start up and see what happens. You know, engine power reduced. And what's the fault code? It revs up and then kind of runs really rough. Let's reestablish communications. ECM. This P0090 fuel pressure regulator control circuit. There we go. Oh, come on. So setting 3 codes: vacuum pump performance, fuel pressure regulator control circuit, and turbocharger boost persistent performance. Last test not run. Okay, this is the one that comes up every time I clear the codes. Let's see, clear DTCs. Yes. Okay. Back out. Key off. Let it go to sleep. Turn it back on. So you want to scan it before you start the car and then after you start the car. Is this a hard circuit fault or is it a performance fault? Let's see. Key back on. Back in the ECM. Read fault code. So right there, it's a hard fault fuel pressure regulator control circuit. Last test failed current. And if we look at live data on this fuel system data, when you unplug these high pressure pumps or you lose a circuit, it should default to high fuel pressure. So let's look at desired, actual, fuel pressure, and then fuel pump or fuel rail pressure sensor. FRP regulator command. Okay. Right there, actual and desired, about 530 psi. So I'm going to start up. Oh, come on. Lost comm. Let me reboot the scanner. All right, hopefully it'll start up and not kill the scanner. Look at that, actual fuel rail pressure, only 60 psi. That's the low side. So this high pressure pump is almost like it's not doing anything. It's just running on the low pressure side. And is that why it's setting this code? Perhaps. Or there could be a circuit fault. Like I said, when you unplug these high pressure pumps, it should default to high pressure and have like a hard ticking sound. If I unplug it, nothing happens. Our fuel pressure stays low. So my next step would be, since we're not hearing loud, you know, direct injection activity, mechanical activity on the high pressure pump, I want to take it off and see if we see anything interesting. Now the history of this vehicle, it didn't run before. The head was taken off and they found bent valves or something, rebuilt the head, put a new high pressure pump on, and now it doesn't run. So is it possible that there's a piece that rides on the cam, like a cam follower, that needs to be there for the high pressure pump to work? I'm going to see if it's there. Perhaps it was, you know, omitted, and that might be the problem. Alright, so I got the high pressure pump off. What do we notice? Most Plus Fuel Systems. Never heard of that brand. And if you smell this side, it reeks of gasoline. There's not supposed to be any gasoline on this side of the pump. So that's suspicious. Now we have the cam follower here. Let's smell that. See if that's also well lubricated or not. The roller's there, so that's not the problem. But this pump is just not doing its thing. I'm probably setting a circuit code. So I'm going to call a bad pump. We need to get an OEM GM pump that doesn't leak, and it should resolve this car's problems. We could do a circuit integrity check on the control wires here, but I'm pretty sure there won't be anything wrong with that. So just junk aftermarket parts here. I'll put that back in. And I don't know if one's available today, but if we pop it in, we'll get an aftershot. Okay, so circuit fault. I measured the continuity through the solenoid, and it was less than 1 ohm, like half an ohm. And there's 2 wires here, high side driver, low side driver. I want to scope both sides and also the current going through this pump whenever the PCM commands it on. So that's 3 channels. See why this code is setting. So let's see, everything's zeroed out. So let's start the car, see if the computer's trying to energize this solenoid, and if not, what is going on? Okay, so I didn't have my current clamp turned on, that's why that was stuck at 0. Let's start it up one more time. Here we go. Increase the channel there. Let's rev it up. Now, is this normal? Sometimes it pulses it, sometimes it doesn't. Boom, right there. Right there. So it basically shut it off. Will it say reduced power? Yes, engine power reduced. Okay, that's fantastic capture there. So it was controlling it for a little while, and then it actually forced itself to shut down. This is neat. So there's the current flow up to 1 amp. It's doing its thing. Let's back up a little bit. So I guess the blue trace, that's the high side, and the low side pulses it to ground. Okay, that's how the system works. So when the car decides to turn off the system and goes into that reduced power state, boom, the blue goes to 0, and obviously then there's definitely no current. Here we had a couple. So my question is, why is there no current when this is high and this is low? There should be quite a bit of current. So here there was up to 1 amp, that's normal. And then, it was working, seems like it was working just fine. Car was pretty happy, actually revved up. Then there's some current there. Whenever there's a voltage differential, we should have current, just by Ohm's law. This is battery voltage. This is right near like 2 volts. So what is going on here? Do we have an open circuit? The data should show us everything we need to know. And why did the car decide finally to shut down the system? I could try it again right here. Had a couple current spikes, then it shut it down. So is this normal? I think this is normal right here. Because the red is at battery voltage. Every time it pulses it down, we have current. So this is known good activity. I even revved it up right here. Everything's great. Everything's fine. There's the current right there. Let's go to the next slide. Something really strange is going on. Like right here, we're definitely close to 0 volts. It's probably trying to boost the pressure. And we have no current at all going through the pump. Is the pump solenoid becoming an open circuit? That's pretty crazy. So putting a good pump, OEM pump on this would fix this car. But this is why you need an oscilloscope. There's no way you're going to find this intermittent problem with an ohm meter, or you get lucky, but they already replaced the pump. So that's how the parts can get out of hand. Right here, there's some current. Let's go back to the known good. This is known good. The red, let's put that cursor right here. The red is staying at battery voltage except for the spikes. Right? Here, this is bad. So once in a while it'll make kind of messes with your head a little bit. When there's a voltage differential, there should be current. But in this case, this state of the driver is just strange. Back here. There's just two states of the driver, high and low, 0 and then battery voltage. Pulse, 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 and this is when it lets it go. Boom, you get a inductive spike. That's good. And what happens when you rev it up? This garbage. It goes to this intermediate state, which is at 2.5 volts, about 3 volts. About 3 volts. There's current there. There's no current when we're doing this crap. There's current there, okay. See these, this is getting weird. And it pulsed it. Just keeps pulsing it. Next page. Oh. There's the pulse. This is very, very strange. But right here, we lose all current even though we're at this low state. It's almost like the pump is becoming an open circuit. So I put a 4 amp bulb in parallel with the actual high pressure fuel pump. Let's see what happens. So right now the current and the drivers are good, everything's great, but I think that the fuel pump itself is not working, that solenoid. If you rev it up, See how the bulbs get brighter and dimmer? The drivers are working, everything's great. Okay, this is test light substitute test, and let's look at this current. Yep, the high side always stays high, and the low side driver, whenever it pulses it, we get nice current. So wiring looks good. The driver in the engine computer looks good. Is that solenoid becoming an open circuit when the car is running? That's the only explanation. Unless the the terminals here are. Should check terminal tension for sure. Check continuity of this thing. I already did. It's less than half an ohm, pretty consistent. Let's do a drag test on these terminals right here. Alright, we might have a winner here. I'm trying to do a drag test. With both these terminals, the pin is just falling right through. Crazy. Let me tighten these up, we'll reconnect it, and maybe this car will actually run decent. Alright, so I couldn't figure out how to get the pins out, but I just put a really thin pick with a sharp 90-degree bend, and I just kind of preloaded the 2 pins, and now when I plug this in, it's tight. Let's make sure the other side is tight as well. Yep. Alright, moment of truth. We don't need the test light. Just plug this sucker in. Okay. Clear the codes out. I think this thing should run perfectly. Alright, all the codes are cleared out. Shut the key off, let the car go to sleep. There's the throttle body. It's fired up. Oh, I killed the battery, dang it. Dude, jump pack to the rescue. Oh, I gotta push the magic button. There we go. Let's wiggle the terminals. That's good. Oh yeah, that's a bad ground there. Okay. Try number 3. Alright, I hear the high pressure fuel pump. Sounds good to me. Let's go into ECM. Scan it for codes one more time. Look at those fuel pressures. I assume they're going to be as good as new, or as good as fixed. Oh yeah. So now we got vacuum pump performance, turbocharged booster system performance. There, DTC one more time. Definitely not saying reduced engine power. It's doing a little surge. Let's see. Shut it off. One more time for good luck. Okay, so this vacuum pump performance, I think someone's already tried to fix that problem. there's a little pressure sensor right here on the brake booster, and it's got wires, rewires, you know, over here. That goes somewhere else. I don't know what that's all about. But the vacuum pump that they're talking about, where does that thing live? Well, let's take it for a spin. I'm not too worried about that right now. We know that the high pressure pump works fine because on our data display, desired and actual fuel rail pressure should be spot on, exactly equal. If we rev it up, it should go to like 1,000 psi. Oh yeah, that's what we want to see. So terminal fretting at the high pressure fuel pump. Wow. Again, I have not seen that exact failure before. But the scope definitely led us in the right direction. The drivers are working, but no current. Vacuum pump relay control circuit, okay, whatever. So I'm going to save these three in a report. And then we'll take this thing for a rip. Alright. It's going. So far so good. No reduced engine power. The owner here is pretty pleased with that so far, right? Probably need some alignment work, or why is it all shaky?
I don't know. It's got any traction
Control active. What if we turn that off? No, it's still. Maybe the wheel's about to fall off, but hey, it's got power.
It says ESC.
Yeah, that's electronic stability control. So it might not. Maybe it's not happy with the ABS. I can actually scan it right now while you're driving. Let's see what's going on in our EBCM. Service ESC. Okay, so it set a code. We got a stability system active too long. Okay, yeah. So is that it was trying to slow you down? Yeah. So maybe it'll shut itself off at some point. But we can look at the wheel speeds and see if there's something weird going on. Left front, left rear. Right front, right rear. Okay. Graph. Does it have the boost? Was that to the floor?
No.
No, okay. Well, the wheel speeds look okay. So I don't know. I think you should have a little more pep than that. Wow. So it's not upshifting. And if you let it off, will it shift right away?
Yeah.
Okay. Just kind of hanging the high RPMs. All right. Well, it's a lot better than it used to be.
100%.
So we might want to go further, or we'll leave it at that. And I'm only here in one day, so
yeah,
it's up to the up to the owner here. If you want to keep going with the check engine light stuff, but that was part one at least. A little bonus footage, that stability control is probably kicking on because when you drive it straight, the steering wheel is cocked to the right, about 30 degrees on the data, 20 to 30 degrees, and the car's probably trying to straighten itself out and just not happy. But once it cancels itself, then then it doesn't interfere anymore. So it needs an alignment. Check the fluids, the vacuum pump stuff, optional, and that's it. All right, so for this vacuum booster pump trouble code, there's actually a TSB where this car had a dealer, not a recall, but an upgrade for a hard brake pedal on a cold startup. They actually add an extra auxiliary vacuum booster pump. That's why this thing looks kind of aftermarket. The booster pump is right under here. Right here. You can see the hose comes up there, and then there's some wiring that looks a little homemade, but that's, this thing right here, that's dealer installed. And the hose splices in here, so it actually helps with the vacuum at the brake booster during a low vacuum situation, because most of the vacuum comes from the intake manifold. And what I found was, in the TSB, they say to upgrade, you install a fuse here, install a relay here. So in position 24, install a 20 amp fuse. Position 8. Position 24, well, there's no relay there. The fuse is still here. So we sourced from a junk pile a relay that should fit. So now let's reset the codes, see if the booster pump actually runs. And I think this car should be mostly fixed. It needs an alignment. That might explain the kind of late shifting, the stability control not being happy, but that'll be taken care of later. Let's reset the codes and see if this vacuum assist code goes away. All right, so we have vacuum pump performance, vacuum pump relay control circuit, turbocharger boost system performance, turbocharger boost sensor circuit high voltage. I'm going to clear all these out. Okay. No DTCs. Shut the vehicle off, reset it, and take it for another. I don't know if we need to take it for another test drive, but at least run it and see if the check engine light pops on right away or not. Okay, read fault code. Vacuum pump relay control circuit. That's still there. And then turbocharger boost system performance. So those two, let's write those down, do a little bit of research on the actual circuit. Now the wiring diagram doesn't show it because it's an aftermarket add-on, but I don't know, is there a bidirectional control to command this pump on? That may or may not be there. Output control. I doubt it. See, I don't know, that's not there because it's an aftermarket add-on. And the car knows that it's there because the ECM was reprogrammed by the TSB. So it's not in the diagrams. There's no bidirectional control, but it's there. All right, so I'm doing some checks at the relay terminals with a test light, connect to ground. So if we look at the relay, pins 30 and 87 are diagonal like that. So one of these is hot all the time. The other one should go to the vacuum pump. We can even feed this like 5 amps, see if the vacuum pump turns on. These are the control side pins. Pins 86 and 85. Now, car's off. Check it out. Bright light there. And bright light on that one. So both pins 85 and 86 have so that's bright. hot all the time. That's hot all the time. You hear something click. That's a control pin. But why would that be hot? So this is definitely the load. 20 amp fuse. That pin should be dead now. Yep. That's definitely the load. I'm wondering, are all these relays the same? 3087, 8586. Yep. They're all the same. These two are always the control pins, correct? Yes. So hot all the time, hot all the time. That goes to the pump. The control pin. What? It's controlled by the PCM, but we have no diagrams. Alright, so not exactly sure about the vacuum pump, but this boost pressure sensor, it's saying 40 PSI. 4 volts. What the heck? The map sensor seems to be reporting accurately. Now, where is each sensor? Quick trick is, if you locate a sensor, you can unplug it, watch scan data. Let's try this one. There you go. Map sensor went to 0 volts. Okay. Now, where is the boost pressure sensor? Usually that's on the intake pipe right before it goes into the intake manifold. Down here by the AC compressor, I think what I found, it's a 4-pin. There's a sensor right here, and there's a pigtail that comes to right here. Let's unplug it, see what happens on our scan data. This could also explain poor performance, obviously, if the car doesn't know what boost pressure it's running. So let's unplug that. I'll let you guys watch the scan data. Let's graph that. So right now boost is 437 PSI. Let's try to unplug this sucker. There we go. We're up to 5 volts, 50 PSI. So that sensor is definitely messed up. I don't know if it's aftermarket. It's not reading the correct voltage whatsoever. You definitely want to make sure that the signal, the ground, and the reference are good. But this sensor does not look OEM. So go figure. Let's try that again. Plug it in. Yep, 4 volts, 37 PSI. Wires look chewed up. Alright, so final call here needs the correct boost sensor. The temperature seems to be reasonable. The map sensor works fine. Looked at the diagram, checked the 5 volt, the ground, everything's good. Signal is showing the correct voltage, but it's stuck at, it's 4 volts instead of, should be like closer to 2 or 1.5 when the engine's off. So needs a new sensor, and for the vacuum pump, I'm not exactly sure how this add-on is wired in, but I don't think that should affect the drivability of the car. Check engine light, maybe, maybe not. But the boost sensor is more important for drivability. It's got to be aligned so the traction control's happy, and that's about it. So there's a follow-up. We'll post that. But for now, thanks a lot for watching. We'll see you in the next one.